Okay, so this is the 2024 Higher Level Applied Maths Leaving Cert paper, question 10. The diagram below shows the scheduling network for manufacturing a car. The edges of the network represent the activities that have to be completed as part of the overall manufacture of the car and are labelled with letters from A to L. The duration in weeks of each activity is represented by the number in brackets. The unlabelled edges shown with dashed lines do not represent real activities, but they help explain the order in which the activities must happen. The letters used to label the edges should not be taken as representing the order in which the activities happen. The nodes of the network represent events or points in time during the project. The source node is the time when the project begins, and the sync node is the time when the project ends. There's our network there. We've got to calculate the early and late times for each event. Complete the diagram. Okay, so we can see here at the source node we've got A, B and C. So it's going to take 3 days to do A, 5 days to do B and 2 days to do C. So they're going to be our early times for A, B and C. So we're going to put in 3 here, and we're going to put in 5 here and 2 down here, and remember we're starting at 0, 0. Okay, so let's get into it then. Now when we come along here to D, we can see here that it's going to take 1 day to do D, but if you look down along here, it's going to take 5 days to do B. So to be at this point here, is it going to be 4 days that we put in here, or is it 5 days? Well, it's going to have to be the larger of the two. It's going to have to be 5 days. So we're going to put 5 in here, because if we put 4 in here, we're going to be waiting a day for B to be completed. So here we've got, we've got this dummy activity coming down along here, so that means we could put 5 here, but we've got 5 plus 7, which is 12, so that's larger, so we can choose the 12. Up along here we've got 2, so it's going to be 12. 12 is the largest of the three numbers, so let's put in 12 there. And then if we look here, we've got 12 coming down here, and we've got 2 plus 4, which is 6. So we're going to put the larger of the two here. That's going to be 12. We're going to put 12 here. Let's look over here from this node to this node. We've got 5 plus 3, which is 8. So we could put 8 there. But we've got 12 plus 4, which is 16. So we can use 16. We've also got this one coming up along here. So I'm going to have to do this one just to see what this is like. So let's come down here first. Let's do 12 plus 3. 12 plus 3, that's 15. We're going to put 15 here. And up here then we can finally do this one. We could have 15 here, but we've got 12 plus 6, which is 18. We got 12 plus 5, which is 17. So we got 17, 18 and 15. So we're going to put 18 here. So this one is going to be 18. And then this one up here then could be 18 plus 1 could be 19. It could be 12 plus 4, which is 16. Or it could be 5 plus 3, which is 8. So the largest of those is going to be 19. So this is going to be 19 up here. So let's put 19 there. Now out to the sync node, we have, we have 19 plus 2, which is 21. We've got 15 plus 4, which is 19. So it has to be 21. Okay, so now we've got to work backwards. So we're going to put 21 here for the late time. We're going to work backwards. What we're going to do is subtract each of the edge weights. So let's say we come down along this way first. 21 minus 4, so there's only one possibility here, that's 17. So let's have a look at this one up here. 21 minus 2 is 19, so we're going to put 19 here. Now this one here in the middle, we have 19 minus 1, which is 18, and that's the only possibility there. So we're going to put 18 here. Let's do the one on the bottom here. We've got two possibilities here. We've got 17 minus 3, which is 14, and then we've got 18 minus 6, which is 12. We're going to choose the least of those two, which is 12, because if we had have chosen 14 here, then coming up along this way, 14 plus 6 gives you 20, which means this one here is going to be delayed. So we can't put 14 here. So 12 goes here. Okay, so let's have a look at this one here in the middle now. So we have, we've got this one here, and this one here. We've got three possibilities coming into this middle one. we have this one, and this one here. So let's see, we have 12, we have 18 minus 5, which is 13, and then we have 19 minus 4, which is 15. So the smallest of those is going to be 12, so we're going to put 12 here in the middle. This is 12. Now let's have a look at this one up here. So we've got 19 minus 3, which is 16. We could put 16 there. We've got 12 here, so we could put 12 here, so that's lower, so 12 is the one we're going to use. Okay, so let's move over to this one here then. We've got 12 minus 1, which is 11, and that's the only possibility there. Here we've got 12 minus 7, which is 5, and down along, so we've got 12 minus 7, which is 5 here, or we've got 12 here, so it's going to be 12 minus 7, so it's going to be 5 here, smaller of the two. And then along here we have 12, we have a possibility of 12, or we have 12 minus 4, which is 8, we're going to use 8 here. And that's it filled out, and that's all we had to do in part 1. Okay, so in part 2 we've got to write down the critical paths, or the path for the network. Now there is only one here, so let's see, we can go from source node out along here, and then we can come along here. We've got 5, 5, and we've got 12, 12 here. And if we add 5 to 7, we get 12, so there's no delay time possible here without delaying the entire project. So we could, if you think about it, come along here. However, if you take 12 and add 5, you get 17, which means this is not a critical path because you can delay by 1 day. Similarly, up along here you might see 19 and 19 and 12 and 12. But if you add 4 to 12, you get 16, which means you can delay H. So we can't come up along that way. So what we're going to do is we're going to come out along this way, and then down along here, along the dummy activity, and then not along here, but up along this way. Because again, if you take 12 and add 6, you'll get 18. So you can't have any kind of a delay there. Similarly, up along this way, if you take 18, add 1, you'll get 19. So again, you can't have any delay in L there. So you just end up coming down along this way then. So 19 plus 2 will give you 21. So our critical path here is B, E, J, L, and M. And that's the only critical path that there is. Okay, let's have a look at the next question. What is a critical path? Okay, I've kind of overdone this a little bit. I've just written down the definition for a total float, a critical activity, and then in red here what the actual answer to the question. So you only really need to do part 3 here in the exam. But a total float time for an activity is the amount of time its start time may be delayed without delaying the project. And a critical activity then has a total float time of 0. So in other words, you can't delay that particular activity without delaying the entire project. So a critical path then, what you were actually asked in the question is, what is a critical path? So a critical path then is a path from source node to sink node which joins only critical activities. So that's it for that part. Okay, so let's have a look at the next question, part 4. If activity K takes 5 weeks instead of 3 weeks, what effect will this have on the critical paths and the time it takes to complete the project? Explain your answer. So I've filled out the same network, but I've just left these two here blank. So what we're going to do is just change this here from 3 to 5 and see what happens. So activity K takes 5 weeks instead of 3. Okay, so what would happen then on the way forward as we move from source to sink? Well, nothing is going to change up along here, but out along this way this is going to change. So we have 12 here, we've got to add 5, so that's going to become 17. And then if we add 4, we'll still get 21. So the completion time is still 21 weeks. So let's work backwards then. If we were to take 21 and subtract 4, we're still going to get 17 here. And then if we take 17 and subtract 5, we'll still get 12 here. So really what's changed is this node here. And what it means is we now have a critical path, another critical path. So what will happen here is we'll go out along this way, out along this way, we can come down here now, and then if we add 5 to 12 we'll get 17, so that means this is K is now a critical activity. And also if we move out along this way, 17 plus 4 will give us 21, so this is our new critical path here. What will happen then is that BEKN is a new second, if you like, critical path, and you can see then that K and N, they become critical activities. So in other words, they have a total flow time of 0. You can't delay K and N without delaying the entire project. So that's really it for that part. Okay, so last question in the exam is part B. A tank of uniform cross-sectional area contains water of height x meters. So this is x, let's say from here to here. Water leaves the tank through a pipe at its base. The rate at which the height of the water decreases is proportional to x. At time t is equal to 0, x equal to h. At time t is equal to 45 seconds, x is equal to h over 3. Calculate t when x is h over 8. We're told here that the rate at which the height of water, so that's the rate at which x decreases, is proportional to x. So in other words, dx dt is proportional to x. So, you know, if a is proportional to b, it just means a is equal to some constant times b. So it's the same here. Dx dt is going to be equal to some constant times x, but the rate at which the height of water decreases is proportional to x, so it's going to be negative here. So we've got to, first of all, separate out the variables here, so let's do that. First thing I'm going to do is bring over the x, so it's 1 over x dx is equal to minus k times dt. So what I'm going to do is integrate both sides, integrate this side, integrate this side. Actually I might just leave that minus k outside there, makes things easier. And I'll put in the limits as well. The limits that we have here, we're told that when time is 0, so I'm going to put time as 0 in here. When time is 0, x is equal to h, so I put h over here. And then we're going up to some time t and some height x. So there are our limits. So let's start this then. Now I'll do it over here. We have the integral of 1 over x, so that's going to be log of x. Put in the limits here, h to x. And then over here we've got minus k times just t, from 0 to t. Okay, so let's just put in the limits. So we got log x minus log h is equal to minus k times, well, it's just going to be t minus 0, so it's just t. Okay, so I'm just going to say, use the laws of logs here. Log x over h is equal to minus kt. Let's convert this from log format to index form, so it's e to the power of minus kt is equal to x over h, or we can just say h e to the power of minus kt is equal to x. Now we're given another bit of information in the question. We're told here that when t is 45 seconds, x is h over 3, so that's what I'm going to use now. So we're told that when t is equal to 45 seconds, x is equal to h over 3, so this is what I'm going to use. We have h e to the power of minus k times 45 is equal to h over 3. So we can see we've got a h on both sides, so we can just divide across by h. E to the power of minus 45k is equal to 1 over 3. So now what we can do is just get the log of both sides again. So minus 45k is equal to the natural log of 1 over 3. That'll finally give me a k value here of log 1/3 over, I'll put the minus out here, 45. Okay, so I'm just going to come up along here now. So we know that x was equal to h e to the power of minus kt. We've now got k, so I'm just going to put k in there. So we know x here, when k is minus log of 1/3 over 45, we know that x has to be equal to h over 8. So that's equal to h e to the power of minus k, so minus minus is plus, so it's going to be plus the log of 1/3 over 45 times t. So you've just got to solve this now for t. So let's work through that. Well, the h's will disappear anyway. We can divide across by h. So we get 1 over 8 is equal to e to the power of log 1/3 over 45 times t. Get the log of both sides, so the log of 1/8 is equal to the log of 1/3 over 45 times t. And really all you've got to do now is just divide across by this thing here. So what you'll find is you'll get t is equal to 85.1755 and so on, and that's in seconds. And that's it for this question and this paper.